Hey guys, it's Miss Johnson and I'm here to bring you our fifth and final notes video for Unit 4. Today we're talking about the zero product property and how we apply it. So the zero product property is something that we use with factoring, but what it says is that if we have a product that is equal to zero, meaning two things that are multiplied to equal zero, then either A is zero or B is zero. Both can be zero. Okay, so if A times B is equal to 0, then either A is 0 or B is 0. So what we're doing here is we are solving quadratics now. We've been spending all of this unit factoring quadratics, factoring equations that had an x squared in them. And now we're going to go one step further and we're actually going to solve them. And we solve them using the zero product property or by applying the zero product property. So now we're looking at an equation. All throughout the factoring unit, we haven't had an equal sign at all. We've just been factoring expressions. Here's our equal sign, which means we need to solve. So let's just look at number one. In number one, I have these two binomials, x plus 6 and x minus 4, that's equal to 0. They're being multiplied together. This should look like the factored form of an expression. It is. It's a factored form of an expression. What this is saying is that if this whole product is equal to 0, then each of these parts can be set equal to 0. So I'm going to split these two parts into each their own equation. So I'm going to have x plus 6 equaling 0. I'm also going to have x minus 4 equaling 0. So I took the two factors and I set them each equal to 0, and now I'm going to solve them both. Solving this one on the left, I subtract 6, and I get x is equal to negative 6. Solving this one on the right, I add 4, and I get x is equal to 4. So I have x equals negative 6 and x equals 4. Okay, now this is not an ordered pair. This is just like a solution to a system. This is not an ordered pair. This is two different values for x. X can be negative 6 and x can be 4. Okay, so that's how we would solve that there. Let's take a look at number 2. In number 2, I have these two binomials that are again being multiplied and they're set equal to 0. So I know I need to solve here because of that equal sign. So I'm going to split them apart into their two separate equations. I have 2x plus 8 equals 0, and also 3x plus 2 equals 0. So when I solve this one on the left, I subtract 8, and I get 2x is equal to negative 8, and then I divide by 2, and I get x is equal to negative 4. So that's one of my solutions. I guess I really didn't mean to box that yet, but that's one of my solutions. The other solution, I would subtract 2 and get 3x is equal to negative 2, and then divide by 3. And I end up with x is equal to negative 2/3. So my two solutions together are negative 4 and negative 2/3. And again, those aren't an ordered pair. It's not an x and a y. It's two different solutions for x. It's two different solutions that make this whole equation 0. That's what we're looking at here. Let's try a couple more. In number 3, I have 2x minus 6 times x plus 4 is equal to 0. So I split them into their two equations. 2x minus 6 equals 0, and x plus 4 equals 0. And again, I can do that because of that zero product property. The zero product property tells me that when I have a product set equal to 0, then each part of the product can also be set equal to 0. So I'm solving both of those here. 0 minus 4 gives me negative 4. Over on the left, I got a positive 3, so x equals 3 and negative 4. Okay, so those are our two solutions. It doesn't matter what order you list them in. If this were a multiple choice test, you probably would see it negative 4 comma 3, just because they like to go in number order, numeric order, but it doesn't matter. You can list it 3 comma negative 4. They're two separate things anyways, so. Let's take a look at number 4. I'm going to split my two products, x minus 4 equals 0, and x plus 2 equals 0. So I'm going to add 4 to both sides, and I get x equals 4, and then subtract 2 from both sides, and I get x equals negative 2. So my two solutions are 4 and negative 2. All right, so now when we look at number 5, this one looks a little bit different. This one is still in trinomial form. It's still written as a quadratic equation. So I have to do a little bit of work here before I can set them equal to solve. I have to factor first. Okay, so we're going to factor this first. Remember that when we factor, we set up that factor x. I have 1 times negative 20, which is negative 20, and I want a product of, or a sum of 1, so that means I'm looking at 5 and negative 4. So I have y squared plus 5y minus 4y minus 20 equals 0. When I group these, I have y times y plus 5 and negative 4 times y plus 5. And that just goes back to factoring trinomials. So y minus 4 and y plus 5 equaling 0. So then I would set these equal to 0, these each equal to 0 and solve. I'd have y minus 4 equals 0 and y plus 5 equals 0. Add your 4 to both sides. Y equals 4, and subtract your 5 from both sides. Y equals negative 5. So my two solutions here are y equals 4, comma, negative 5. In number 6, again, I need to start by factoring. I'm just given a quadratic here, so I'm going to start by factoring. My product on the top is negative 36, and my sum on the bottom is 5. So my two numbers are going to be 9 and negative 4. I split that middle term, so 6p squared plus 9p minus 4p minus 6 is all equal to 0. And then I can group that. From the first group, I can take out a 3 and a p, and that leaves me with 2p plus 3. From the second group, I can take out a negative 2, which leaves me with positive 2p and positive 3. Still all equal to 0. I should have had that written over here, sorry. And then my factored form is 3p minus 2 and 2p plus 3, still all equal to 0. Then we split them and solve. So 3p minus 2 equals 0. That's 3p equals 2. Divide by 3. P is equal to 2/3. Over here, 2p plus 3 equals 0. 2p is equal to negative 3. And then divide by 2. P is equal to negative 3 halves. So if I were going to write this out together, I have P equals 2/3 and negative 3 halves. All right. A couple more like this, a couple more factoring. In number 7, I have P squared minus 2P minus 35 is equal to 0. So I set this up. Set up my factor x. I have a negative 35 product for the top and a negative 2 sum for the bottom. My numbers that I'm choosing here are going to be negative 7 and positive 5. So split that negative 2 in the middle. I have p squared minus 7p plus 5p minus 35 all equals 0. Then I group and pull out the p to give me p minus 7. Pull out the 5 to give me p minus 7. Still all equal to 0. My two factors are p plus 5 and p minus 7. So again, here's where you're going to take that one step further. Since I have this equals 0, that's what tells me I need to actually go one step further and solve this, because I have an equation here and not just an expression that I need to factor. So p plus 5 equals 0. That's p equals negative 5. P minus 7 equals 0. When I add 7 to both sides, that's p equals 7. So my two solutions are negative 5 comma 7. And there we have it. Okay, one more like this, and then we will move on to some application questions. In number 8, if I set up my factor x, I've got 6 times negative 12. Back up. When I take a look at number 8, I have 6r squared minus 14r minus 12. The first thing I notice about those is that they're all even. I can divide all of these by 2. I'm going to take out a GCF. And all that does really is make it a little bit easier to factor. So when I take out a 2, I have 3r squared minus 7r minus 6. And then that all equals 0. Now I'm going to factor what's left over in the middle. So then I have 3 times negative 6, which is negative 18, and the product is going to be negative 7. That gives me a negative 9 and a positive 2. So split that 7 in the middle. I have 3r squared minus 9r plus 2r minus 6 is equal to 0. I group those, and I pull out a 3r, leaving me with r minus 3. And I pull out a negative 2, leaving me with r minus 3. I'm sorry, that should be a positive 2 because this is a positive 2r minus 6. So pull out a positive 2, leaving me with r minus 3, and that's all equal to 0. Putting your factors together, you have 3r plus 2 and r minus 3. Okay, so now this GCF comes back down and is part of my factored form. Now, let's talk about what that GCF does. Now, I could set this equal to 0, but if I think about what that 2 does, there's no r in that 2. So it's kind of like if I get rid of that 2 by dividing, 0 divided by 2 is still 0. So that 2 didn't come into play as far as finding my solutions. Oops, sorry, that should be a 2. As far as finding my solutions go, because when I cancel it out, it doesn't change the 0 that was already there. Since there's no r with it, I'm not worried about it being a factor in my solutions. If there were an r with it, if there is a variable with that GCF, now all of a sudden it becomes part of your solutions. But since there's no variable with that GCF, I don't need to worry about it. So I'm really just worried about the 2 factors in the middle. I have 3r plus 2 equaling 0 and r minus 3 equaling 0. Over here, subtract the 2, I get 3r equals negative 2 and divide by 3. So r is negative 2/3. On the right, add the 3 and I get r is equal to 3. So my two solutions are r equals negative 2/3 and 3. Two solutions here. So I have two solutions to most of these trinomials. Sometimes those solutions end up being the same, and then you really only need to list it once, but most of the time you're going to end up with two solutions there. All right, let's flip over to the back and let's talk about these application questions. So in number 9, it says a flare is launched from a life raft. The height h of the flare in feet above the sea is modeled by the formula h is equal to 100t minus 16t squared, where t is the time in seconds after the flare is launched. Let h equal 0 and solve the equation for t. How many seconds will it take for the flare to return to sea? So we are going to solve this when h is equal to 0. And the reason we're solving this when h is equal to 0 is because we want to know when it gets down to sea level. And height at sea level is 0. So let's take a look at the equation that we have. This is 100t minus 16t squared. Now, I like to write my equations in standard form. This squared term is second. I'm going to move it so that it's in the front. So that gives me 0 equals, keep the negative with it, negative 16t squared plus 100t. All right, so now I'm going to try and solve this. Well, if I factor this, I only have two terms. I don't have that constant over here. So really, I'm just looking for a GCF that I can take out. If I look at negative 16t squared and 100t, I know that both of those are going to be divisible by 4. I also know that I can take out a t from both of those. So that's what I'm going to do. I'm going to have 0 is equal to 4t, and then behind it, look at what's left. Negative 16 divided by 4 is negative 4. T squared divided by t is t. 100 divided by 4 is 25, and t divided by t goes away. So now I've factored this, and this was just GCF factoring. This was just that very first day of notes that we looked at in this whole unit. I didn't have that constant. It wasn't a trinomial. I didn't have to use the factor x. I just needed a GCF because I had a squared and a t term. Okay, now when I take those two parts and set them equal to 0, here's what I have. I have 4t equals 0, and I have negative 4t plus 25 equals 0. Over here with 4t equaling 0, dividing by 4 doesn't change it. I still end up with t equals 0. On the right, subtract the 25, I end up with negative 4t equals negative 25, and then divide by negative 4. I end up with t is equal to 6.25. Okay, so those are my two solutions, t equals 0 and t equals 6.25. Now, these are the two times that the flare was at ground level. Obviously, the t equals 0 is when it started. If time is 0, then no time has passed since we started this whole scenario. The t equaling 6.25 is after the flare goes up in the air and then returns back down to the sea level. So this is the 6.25. That's the answer that we're looking for. So this is the one we want. That one's not going to help us. And your answer is 6.25. Don't forget to label it. We're talking about seconds here. All right, let's try number 10. And number 10, it says the length of a rugby field is 52 meters long, then it's longer than its width. Write an expression for the area of the field. If the area is 8,160 square meters, what are the dimensions? Okay. Rugby league field. This tells me I'm looking at a rectangle. 52 meters longer than its width. The length is, remember that word is means equal, 52 meters longer than its width. So the first thing that I need to know is, what am I trying to find? I'm trying to find the dimensions of the field. So I'm going to call L my length, and I'm going to call W my width. Okay, so I always label my variables and figure out what it is I'm trying to find. Now, I'm also using area, and I'm using area of a rectangle to be specific. So that means I'm going to be looking at area equals length times width. All right, so now I can't do anything when I have two variables there. That's not going to help me. So I need to figure out how I'm going to fix that. Well, I know that the length is 52 meters longer than the width. I have length equals 52 times W. This is like a system. You just wrote two equations, okay? So now I know I can take this 52 plus W and I can plug it in for L. So that gives me area equals 52 plus W times W. And then the other thing that I'm told is that the area is 8,160. So I'm going to go ahead and plug that in for my area. 8,160 equals 52 plus W in parentheses times W. Now I can finish solving. So now I'm going to distribute this W. So I have 8,160. 52 times W is just 52W. And then W times W is W squared. Okay, I want to solve this. I can't solve this as it looks right now. I need to set it equal to 0. So I'm going to subtract this 8,160 so that it's equal to 0. And I'm also going to go ahead and take the opportunity to rewrite my equation in standard form. So squared term comes first, then the middle term, then the minus 8,160 behind it. Okay. Now, 8,160 is a large number. It's a pretty big number to think about. So when you're setting up a factor x, it might take you a little while to think about what multiplies to that, negative 8,160. But after some messing around in my calculator, I figured out that I needed 120 and negative 68. And that's just where you need to guess and check. Start dividing 8,160. I know it's divisible by 10, so I started there, and I just kind of worked my way up until I got to a number that worked. So this gives me a sum of 52 and a product of negative 8,160. So that's what I'm going to split my terms into. So I end up with W squared plus 120W minus 68W plus, or sorry, minus 8,160. And then if I factor those, from this one I can take out a W. That leaves me with W plus 120. From this one I can take out a negative 68. which leaves me with w plus 120. So I have 0 equals w minus 68 and w plus 120. So I'm solving for the width here because that's the only variable I have left. I got rid of length when I plugged in that other equation using that system that we wrote. So this one is going to give me w equals 68. This one is going to give me w equals negative 120. Now we're talking about dimensions here. We're talking about an actual length of a rectangle. So if I think about these two options, this w equaling negative 120 doesn't make sense because I can't have a negative dimension. I can't have a negative length of a rectangle or negative width of a rectangle in this case. So I know that my width is 68. So width is 68, and let's just check here. Meters is what we're looking at. Makes sense. We're talking about rugby. That's usually European. So 68 meters, which means my length is going to be 68 plus 52, which is coincidentally that positive 120. And I got that, by the way, from just plugging it back into the original equations that I had up at the top. This one right here. Length is 52 plus W. Okay, so that's my length and my width. There's my two dimensions, and I found them by factoring the quadratic and setting it equal to 0 and solving. Let's try number 11. It says at a pep rally, small footballs are launched and the cheerleaders using a slingshot. How long does it take the football, or how long is the football in the air before it touches the ground? And your hint is that, again, h is equal to 0 when it's on the ground. Use the equation given to you. So I want to know where this thing is going to equal 0. So that means I have 0 equals negative 16t squared plus 20t plus 6. Now, when I look at this equation, I recognize that there's a GCF that I can take out. These are all divisible by 2. So I'm going to take a 2 out first, which leaves me with 2 times negative 8t squared plus 10t plus 3. Now, again, really all that GCF is doing, taking that GCF out, is helping me factor it a little bit easier. Okay, so now set up your factor x with the thing in the middle. I'm going to have a negative 24 on the top and a positive 10 on the bottom. That means I want negative 12 and positive 2. So if I split that 10, remember that GCF is just going to come down to the bottom. We'll come back to that. So I have negative 8t squared minus 12t plus 2t plus 3. So now I group them, and when I group them, in the first group I recognize that both terms are negative. Since both terms are negative, I'm going to divide out a negative. I can also take out a 4 and a t. So that gives me negative 4t. That leaves me with a positive 2t. And then negative 12 divided by negative 4 is positive 3, and t over t cancels. From this second one, I can only take out a 1. That's all I have. And that does leave me with insides that match. So my factored form is negative 4t plus 1 and 2t plus 3. Remember that 2 is still out front as your GCF. And now when we go to solving this, the 2 is not going to be a factor because if I divide by 2, that cancels that and it doesn't make any difference. So I really just am looking at the two factors in the middle that have the t's with them. Since that 2 out front didn't have a t, I don't need it. Okay, so set these each equal to 0 and solve. I end up with negative 4t plus 1 equals 0 and 2t plus 3 equals 0. Subtract your 1. I have negative 4t equals negative 1 and divide by negative 4. So I have t is equal to positive 1/4. Okay, over here, negative 3, 2t is equal to negative 3, divide by 2, t is equal to negative 3/2. So when I look at these two solutions, okay, I need to back up a second here. I just recognized a mistake that I made. Oh, Hate it when that happens. Go back to my original factor x. I said that I wanted a negative 12 and a positive 2. This should have been reversed. This should have been a positive 12 and a negative 2. All that really does is change these. And I'm very sorry about that. So go back and change that. That's going to make this a negative 1. And so that makes this a minus 1 in here. And that makes this a minus 1 in here. Those of you that caught my mistake, good for you. So this is going to be a positive 1, and that's also going to make my 2t a minus 3. So those become minus as well, because once I pull out that negative 1, I've now made that a negative 3. Okay, holy cow. So what happens here is I have a positive 1 divided by a negative 4, which is negative 1/4, and I have a negative 3 divided by a negative 2, which gives me a positive 3/2. So I end up with two solutions, t equaling negative 1/4 and t equaling positive 3/2. And I know that I can't have a negative time. I'm talking about time here. So my negative time is out. That's t equaling 3/2, which is really just 1.5 seconds. And that is my solution. Okay, last question. So I'm talking about a gymnast. She is making a vault. She's leaving the horse 8 feet with an initial upward velocity of 8 feet per second. We use that equation there. You're going to start to recognize this negative 16 is in this equation a lot. That's because negative 16 t squared has to do with the gravitational pull, and gravity is always the same. So our gravitational pull is usually going to be that negative 16 t squared constant. I need to take this. I want to find her when she hits the floor. That's h equaling 0. So I have 0 equals negative 16t squared plus 8t plus 8. And then I am going to factor this. So I start with dividing out a GCF. I have a GCF of 8, so I'm going to take an 8 out of all of these. That gives me 8 out front with a negative 2t squared plus t plus 1. And then I factor what's in the middle. Now, I'm not going to go through all of the factoring steps with you. I'm just going to show you what I got after I factored it. I think you've done enough factoring by now to know where I would need to go next. So my factored form here is going to be negative 2t minus 1 and t minus 1. Now we've talked about this a couple times already. This 8 out front doesn't actually do anything because when I divide 0 by 8, I still have 0. So I just need to worry about splitting these two. Negative 2t minus 1 is equal to 0, and t minus 1 equals 0. This one gives me a positive 1/2. I'm sorry, a negative 1/2. When I solve over here, I end up with t is equal to negative 1/2. This one, I end up with t equals 1. So these are my two solutions to this quadratic. When I solve these, I'm looking at time again. I'm looking at seconds. This negative 1/2 doesn't make sense, so that one's out. I'm looking at the positive 1, so I know 1 second is when she comes back down to the ground. All right, that takes us to the end of our video. Thanks for listening today. That's the last video for Unit 4. You made it through Unit 4. We're almost to the end. So thanks for listening, and I will see you later.